start with systems of inequalities. So systems of inequalities, we're dealing with linear systems and nonlinear inequalities. That's the step up here. We'll start with a pretty easy one. Negative 3x plus y is greater than negative 7. And then 2x minus y is greater than or equal to negative 4. That's our system out of that. And with systems of inequalities, the graph is the answer. It's not one ordered pair that we're looking for. With that, we're looking for basically an infinite number of ordered pairs. We're looking for the overlap in the shading of the graphs. That's, y'all remember doing this from Algebra 1 and Algebra 2, and I think you did it in geometry, may have, but the idea here is that we're going to graph both of these. So in order to graph these two equations, they're linear, so we need to get them in what form? Slope-intercept form, basic, just good old Algebra 1 style problem here. Y is greater than 3x minus 7. And then the other one, a little bit more difficult to do, but not too bad. Negative y is greater than or equal to negative 2x minus 4. Divide by negative 1. And that'd be 2x plus 4. And the symbol does what? It flips. Anytime we multiply or divide by a negative, we are going to flip that symbol. Okay. So those are the two that we're going to graph. So we're just going to draw a coordinate plane, graph those two equations or inequalities, shade them correctly, and we should have an answer. I'm going to make sure I got plenty of room. Looks like the y-intercept's negative 7 and then positive 4. So I got to have a good bit of room in both directions. So I'm just going to put my there. I'm going to graph that first one. Y is greater than 3x minus 7. So I go down here to negative 7. 2, 3, 4, 5, 6, 7. Put a dot. And my slope's 3. So I'm going up 3 over 1. Up 3 over 1. I could do that forever if I wanted to. What else do I have to remember about graphing that particular line? Why is it a dashed line, not a solid line? Yeah, the equal to mark's what makes it a solid line. So the no equal to mark means that's going to be a dashed line or dotted line, whatever how you want to describe that. I'm just going to extend that down a little bit. And then shading. How do we decide which direction to shade that? There's a couple of different ways. I'm a test point kind of person. That's the way I like to do it, is pick a point that's on one side of the line or the other and test it. And this one, if I pick 0, 0, that's an easy one to plug in, right? So anytime the line doesn't go through that, I can use it as a test point, plug it into this equation. 0 greater than 3 times 0 minus 7. So is 0 bigger than negative 7? Yes. So we're going to shade the true side. So I would shade the side 0, 0 is on for that particular inequality. And you just lightly shade that. You're going to need to be able to see your grid still. So make sure when you're shading with pencil that you're not getting it so dark you can't see your grid to graph the other inequality on there. So second one, y-intercept positive 4. Slope is positive 2. Keep going with that. Go down a little bit this way. Is this one a solid or a dashed line? Solid. It has the equal to mark. That. Shading, again, the idea here, test points, the way I like to do this, y is less than, so 0. I can use 0, 0 again because the red line doesn't go through it. So as long as the line doesn't go through it, you can use the origin, which is the easiest one to plug in. So 0 less than 4. Is that true or false? true. So I'm going to shade the side that 0, 0 is on. So we're always going to, if it's true, shade the side that the origin's on. If it's false, go to the other side. So that would overlap happening for our shading here in this green area. That's what mine does. Yours, if you're just shading with a pencil, is the darkest area. I use a highlighter here because I can't shade lightly with the pen on the computer. It's either on or it's off. So the highlighter you can still see through. So that overlap, this is your solution area here. So if you're ever drawing a graph and you're not sure if I can tell if it's overlapping there or not, point to it, saying that's the solution area. Tell me where your overlap is, especially when you get to those that have like 3 or 4 of them, and it overlapping 3 or 4, it can get kind of jumbled in there. So sometimes pointing in there. Now with the graphing calculator, you can get it to simulate this. There's an app that works with the calculator, but I'm not showing you that because you're not technically not supposed to use that. So it's not allowed on ACT. So I'm going to show you how to do it with just normal graphing calculator functions. Clear out some of these nonlinear systems that we've been working with. And so I'm just getting y by itself on those, and got 3x minus 7. And I'm going to go over to the left, and if you got the color one, you hit enter right there, and it's going to come up with this little menu as to what do you want to do. Okay, I want to change that from a line into a shading type thing. So it says y is greater than, so I need above the line, which is that one. And hit enter and enter again. Look what happens when I graph that one. We're going to graph the other one too. That's the same thing that I got when I graphed it, on paper. It's the same shading that happened. Nothing different about that. And then when I go to y equals, I can go to the second one and do y is less than or equal to 2x plus 4. So 2x plus 4. And I'm going to go over here. And it's a less than, so I want the triangle in the bottom half. So hit enter. And I want to press the right arrow to the triangles in the bottom half. So less thans are bottom halves, greater thans. And there we see that same overlap here in the middle, purplish area for this one. So that's pretty cool that it'll simulate what's going on. Well, can't change that equal sign to a inequality symbol without the use of an app, but you can, just to basic knowledge that, hey, if it's when you get y by itself, is y is greater than, then you're looking for that triangle in the top half. And if it's y is less than, equal to mark, the only thing the equal to mark does to the graph is what? The line, solid or dash. That's the only thing it does. So we don't worry about that too much when we're trying to just see if our graph looks right. So greater than's, it's triangle at the top. Less than's triangle on the bottom. If you got the black and white one, I'm going to go through what it looks like because it doesn't have that menu thing. Okay. So you guys that have the older version there, I'm going to swap my emulator to look like that real quick and show you that. Give it a second. It flips over. Okay. So I done one of these Monday night when I was teaching. So the only thing your doesn't do is reset when you get clear. You'll have to reset it on your own. So I would type in the same equations, 3x minus 7. And then over here I just press the left arrow till I got to there, and it was y is greater than that. So I'm just going to hit enter until it changes to the triangle up top. You don't get the nice menu thing that comes up, which it does the same thing. And then when I graph it, I see the same picture. It's just black and white. Okay. And then I go to y equals, and the y2, I'm doing 2x plus 4. And then I go over here to the left, and I'm hitting enter until I get the triangle in the bottom, which should be right after the triangle on top. Hit graph. Same picture. It's not quite as, high resolution and color.